2.1, increasing, decreasing, and piecewise functions. So we're just going to look at a few different graphs. They have a few graphs on page 158 where the section starts. And we can look at a graph of this thing. This graph is always increasing, whereas this graph is decreasing. Okay, that one's not hard at all. It's just where your slopes are positive and negative. Then you run into pieces that change, and we'll just talk about where those things change at. So for example, they have a graph about like that, and we can kind of say that about right in here it changes between increasing and decreasing. So between here, this is increasing, and on this side of it, it's actually decreasing. So remember looking at the number lines, and they had your parentheses or square brackets from the last section. They put parentheses here because it's not increasing or decreasing at this point. This actually, if I were to take the slope at this one individual point, it would actually be a flat line at that point. So it's not considered increasing or decreasing right here. So these are not included. Okay, and then I might have a couple other graphs. Like they show an absolute value graph. So it looks like this thing. So if I had that graph, this would be decreasing. Whoops, that's not what I want. So it'd be decreasing from here to here, and then it'd be increasing on this right side. So this is decreasing, and this is increasing. Okay, I'm always looking at it from left to right. And then it talks about a constant function. So a constant function is going to be a straight line. So this would be a constant function. Okay, I actually have a zero slope, not undefined slope, a zero slope. If I were to see an equation for this, it would look like y equals 5, or y equals some number. There's no x's in my equation. So you can look at the graph and tell pretty easily, but they're also going to give you sometimes some numbers and ask you to decide whether it's increasing or decreasing. So we'll just do a few examples of those. So I'll just draw out a few different graphs. Okay, this is an example of the first one that they have on 159. So I'm going to take, I have a couple points here. Okay, in general, they would call this a f of a. That is my xy term. My x is my a, and this would be b f of b. So when I'm actually doing my function values, this would be considered a, and this would be considered b. This point here would be f of a, and this point is f of b. So for our example, in this case, our a is 1, our b is 1, 2, 3, 4. Our f of a is 4, and our f of b is 6. So this point would be 1, 4, and 4, 6. So what they're going to do, they have this definition. So it's increasing. If a is less than b and f of a is less than f of b. That is what it means for increasing. So a is less than b, so is 1 less than 4, and 4 less than 6. So sorry that I used 4 in both places. This is this 4 right here. And this guy is right here. Okay, 1 is less than 4 and 4 is less than 6. Good. That means that it's increasing. I'm just going to write a big I. Okay, so if they asked you to do it algebraically, this is what it would look like. Then they might have something like this. So here's a couple good points that we can use. Okay, this one we can see that it's going down, so it's decreasing. And it's said to be decreasing if A is less than B. So we always set it up that A is less than B. And f of A is greater than f of B. So in this case, this is our A, B, oops, this is our f of A actually. And this would be our f of B right here. Okay, so f of A, so A is 0. My B point is 2. I need to stop using all the same points. Okay, so that would be, because this is 0, this point is 0, 2, and this point is 2, 0. And then 2 is greater than 0, so that means it's decreasing. If it's constant, I imagine you can figure out what it would be. That it will basically say if A is less than B and f of A equals f of B. Okay, this could be my A and my B. So this is f of A and f of B because they're the same y values. So in this case, I would have 2 is less than 5 and 3 is equal to 3. So that is constant. You probably will not ever have a problem telling if it's increasing or decreasing or constant. Mostly you can look at the graph for it. But those are your actual definitions, and they're on page 158. Some of your questions for increasing, decreasing, and constant functions, you will just have something maybe that looks like this. And then let's draw some other lines. Okay, so we would write increasing. And we're going to write everything in interval notation, so I just looked it up. So this would be -5 to 2 to -2. So I tried to leave an open dot at -5, so that will have a parentheses, and a closed dot at 2, which will have a square bracket. It would also be helpful if I was looking at the right thing. This was actually the constant piece. Sorry about the confusion. Then it would be decreasing, and it would be decreasing from 2, we'll have an open dot here, and a closed dot here, and an open and another closed. Okay, it could be decreasing from -2 to +2. We are always looking at our x values for increasing and decreasing. Ignore the y values, which is sometimes where people actually get confused at. Now for the actual increasing one, it happens at 2. It's closed, or it's in parentheses because it's an open circle, and it goes to 2, 4, 6. If you had more than one set that kept going, whoops. So let me just move that. So for example, if I had another set right here, that looked like that. Let's just leave an open circle since we haven't had 2 open circles. This is also another decreasing, so it's going to be decreasing from 6 to 8 and 11 with another open circle. And you would just separate them with a comma. And then it talks about relative maximums and minimums. When we have more than one maximum, it's actually called a max. Or if we have more than one maximum, it's a maxima. If we have more than one minimum, it's called a minima. They're relative mins and maxes. Um, so relative minima and maxima. A lot of times they're also in other books called local minima and maxima. And a lot of times you'll hear me say local min. I'm not talking about going and finding a date. I'm talking about local minima. So if I had a graph of just some, let's call this some like quadratic graph or quartic graph actually. We're going to find some local minima and local maxima, or relative. Your book uses relative. I'm more used to using the word local. This could actually be the highest point of the entire graph since it's higher than this or this. But then when I talk about actually finding the minimum, if you notice that it goes down forever. So it's going to keep going down and the value is going to get less and less. But we're not actually talking about the extreme minimum or maximum. We're just talking about those local ones. And sometimes in this case, right up here on the top left, they actually are. This is the highest point of the graph. Okay, and then this is also a maximum. And we're basically just look at if we were to zoom in really close and what I have circled, this point right here is higher than these 2 points on the other side of it. This point down here is lower than the points on the side of it. So that's how we determine maximum and minimums, or relative maximum and minimum. So for an example like this, you might actually, they'll ask you to say where the relative min and maxes are. So in this case, we would say, well, you would just kind of estimate whatever these points are. Most of the time, they're going to give you the actual point on the graph. So I have a absolute max at my y value. So my y value looks like it's about 3. And that happens at x equals -2. If you also just wanted to write like -2, 3, I'd be all right with that as well. And then I have a relative max, which happens at x equal, or my y is equal to about 2.5. And that happens at x equals 2, 4, 5. Okay, again, if you wanted to write it as 5, 2.5. Okay, and then I have a relative minimum, or a local min. Oops, I can't spell. So my minimum. And you wouldn't have to list the absolute and the relatives separately. Most of them will just have one, so you won't have to worry about doing them separately. You'll just say relative max, relative min. So your relative minimum happens, your minimum is about y equals -2. And that happens at x equals about 1.5. So I have 1.5, -2. Also, what it asks you is to say where it's increasing and decreasing from. So those minimum and maximums are actually going to be what change it. So it would be increasing up to here, and then it's decreasing. And then it's increasing again, and decreasing forever that direction. So this is ID, ID. Then what we're going to do is we're going to list them in interval notation. So my increasing function, it goes from -infinity up to my x value right here, which is -2. It's also increasing from 1.5 up to 5. Have to count there. It's decreasing from -2 to 1.5. And then it's also decreasing from 5 to negative or positive infinity at this point. Okay, because that's this guy right here. The other piece it might also ask you to do is domain and range. So maybe you're increasing and decreasing. So then your domain is my x values. In this case, it's going to go left and right forever. So it would be all real numbers. And my range, so what's the highest y value that I have and everything underneath that. So my highest y value is at 3. So I would write y is greater than, oops, I'm sorry, less than, I had it written out right, less than or equal to 3. In interval notation, it would look like everything underneath -3, or +3, I'm sorry. But since it's included, it would go up to it. But since this point right here is below 3, it's -infinity to 3. I think I've noticed some people trying to write like this, and don't do that. Make sure if it's -infinity that you're writing it on the left-hand side. Okay, the next type of function you see are called piecewise functions. You've probably seen a little bit of these guys again. So here's going to be my graph. Okay, and then I will be given something that will look like f of x. And they can change your variables on you, don't worry about it. This is just the enclosure bracket. And it says my function equals x plus 1 for all my x's that are less than -2. And then it's equal to 5, which is going to be a constant function between -2 and 3. And then it's also equal to x squared for x is greater than 3. Greater than 3. Okay, what I like to do is plug in points in order to graph these. So some of them ask you to graph them, some of them just ask you to evaluate them. So in this question in the example, it asks you to find f of -5. So you have to decide where -5 falls at between these right-hand numbers. We're completely ignoring this half right now. So -5, is it less than -2, between -2 and 3, or greater than 3? So since -5 is less than -2, I can plug it in for that x, and it's a true statement. I'm going to plug it in to this equation. So I will have -5 plus 1. That means that my f of -5 equals -4. Then it asks me to do f of -3. So where is -3 at on these right-hand things? Let's make that look more like a -2. Since -3 is still less than -2, I'm going to plug it into this top equation. I'll have -3 plus 1. So that f of -3 equals -2. And the next thing they give me is f of 0. Where is 0 at in these three equations? 0 would fit in here to make a true statement. So that would work here. So I will plug 0 in to this equation. Since there is no x's to actually plug it in at, f of 0 equals 5. Okay, let's try f of 4. Where does 4 fall at in these equations? Since 4 is greater than 3, I could write a 4 here and make a true statement. Okay, so I will plug it into this equation and I will get 4 squared. So f of 4 will equal 16. Okay, so maybe an f of 10. F of 10, since 10 is greater than 3, I will get what is 10 squared. So f of 10 equals 100. So if I were to graph that, I can plot points, I can plug things in, but that's not actually what I like to do. Let's do one more point at this point. So f of 3 is equal to which one? So I could plug 3 in here. Since 3 is less than or equal to 3, I actually get out 5. So these are all my function values so far that I have. Okay, I can make a table of values if I wanted to, if I needed help to graph things. But what I always do is I just kind of go back to my basic functions. So x plus 1, I know I have a graph that will go through at positive 1, and it will have a slope of positive 1. So I will go back a few places. And then I go ahead and I actually make that graph. Okay, so that is my graph of this first thing. So that's this thing. That was my star. And then I have a graph of 5. So I'm going to go up 1, 2, 3, 4, 5. I really shouldn't have done red. Okay, my graph of 5 again. And then x squared is one that right now we'll probably just use points to plot it. Let me pick out purple color. So I will have 0, 0. 1 squared is 1. 2 squared is 4. 3 squared is 9, which is going to be way up here. We'll just do it at the top. Okay, so it's going to be a parabola. When we get done, we'll probably actually not have anything left on this graph. Let me try to move it down. Okay, and then I'm going to go back to my marker. At 3 squared, I have 9, so 2, 4, 6, 8, 9. That will actually be right there. At 4 squared, I would have 16, so that's 10, 11, 12, 13, 14, 15. That one is way at the top, actually. So quadratics get very steep very fast. And I would have the same thing on that left side. So I basically have 3 graphs on top of each other. And then I'm going to erase. So at negative 2, I actually should only have this function. So less than this value, I will actually, so at negative 2, I will be right here. And it should have an open dot. Okay, past that, I'm going to erase this blue line. Okay, so that only exists down here. And then it has an arrow. Okay, let's keep drawing this guy. And then between negative 2 and negative 3, so right here, and these have closed circles, I am on the 5, so I'm using this function, and then I'm going to go all the way up to positive 3. They have both closed circles. I erase everything on both sides. And then x squared, I have this for everything greater than 3, so it'll go up forever, and it keeps getting bigger, taller wise, and x-wise, so x and y's. So I have an open circle at 3, so let's make that more of an open circle, and I erase everything that was underneath it. And that is what my piecewise graph would look like when it asks you to graph them. If you didn't really know what your graphs looked like in order to do that, I could just set up an XY table. And I could have my x's. I'm going to start below -2. So I would have -3. And I want to make sure I include all of these numbers and then one in between them. So I could do -3, -2. I'd actually want 2 of them below that. So I would want -4, -3, -2, maybe 0, 3, 4, and 5. So what I would do is make sure you get 2 to 3 points in each of these x values, or yeah, for your x values. And then you'll evaluate them. So at -4, I should be down here at -3. You would actually plug in, and you would go -4 is less than -2, and I'm going to plug it in. Since we already actually have -5, we could have used -5. And we can just use these function values that they give us and add a few more in order to actually get what this graph will look like.
I don't actually, let's not do word problems, so I will just have you guys do 1 through 20. And then you can do 39 through 44, 53 through 58, and 59 through 64. 59 through 61. How about that? So I don't have my little writing thing here. So again, that was numbers 1 through 20, 39 through 44, 53 through 58, and 59 through 61. How about just 53 through 61?